Now, I said at the beginning that chapter 2 is probably the most important chapter, and the next topic we're going to do is the most important part of the most important chapter. The power of units is the secret to solving almost all of the chemistry problems that you're going to have in this class. So we're going to talk a lot about doing problems, doing calculations. We're going to start with problems that look like they have nothing to do with chemistry, such as how many inches are there in 2.5 feet. But this is going to show you a method that if you use this method and understand it, then the chemistry that we get to later on, which is going to be more complicated because it's not something you're used to in your everyday life, the way you are used to inches and feet, it's going to make that part a lot easier. So the key is you want to find the known and the unknown in this problem. The unknown is usually the easier one because it's given away by the how many. So the unknown in this problem, the unknown is inches. The known is oftentimes more difficult to find, but what we know we have is 2.5 feet. So we're going to set that unknown, and we're going to use x as the unknown, and the unit that we want is inches. We always write that on the left, and then we write an equal sign, and we want to set that equal to the known, which is 2.5 feet. Then we use conversion factors to turn the known, turn the known into the unknown. And this process is called dimensional analysis. So the units are going to tell us exactly what we have to do at each step. This is not something you need to memorize because every problem is a little bit different. What you do need to memorize is set the known equal to the unknown and then let your conversion factors do the work for you. We are looking for inches and we're starting from feet. Now sometimes you have to look up some relationships. In this case, we know the relationship that 1 foot is exactly 12 inches. This is a definition, so that's why I use the 3-bar equal sign. I'm going to use this. This is my conversion factor. I have 2 units. I can relate feet and turn them into inches, or inches and turn them into feet. That's what I mean about a conversion factor. And I'm going to use this conversion factor. I'm going to write a times sign and a line. The key is this unit feet has to go in the denominator of the next conversion, because when we multiply through, this unit has to cancel with this unit. So the feet have to go in the bottom, and I can turn feet into inches, so I'm going to put the inches in the top. I'm using this relationship, and notice it's very important to notice I put in the units, but I haven't put in any numbers yet. The most common mistake with this technique is to put in numbers before you're ready for them. You cannot put in numbers until you know what the units are. So once I have the units, then I'm going to use these numbers from the conversion factor. 1 foot is equal to 12 inches. So I fill in those numbers, and notice this conversion factor, this fraction, doesn't look like it equals 1, but it actually does equal 1, because the top and the bottom are exactly the same. If the top and the bottom of a fraction are the same, the fraction equals 1. That's important because I'm not multiplying the left-hand side by anything. The only number I can multiply the right-hand side by and not change the value is by multiplying by 1. This looks like it doesn't equal 1. It looks like it equals 12. But because of the units, 12 inches matches 1 foot exactly, this fraction does equal 1. And when I multiply through, the feet are going to cancel, and I'm left with the unit I want, which is inches. So when I multiply this out, I'm going to get 30 inches on my calculator. Remember, we have to worry about rounding it, and we have to worry about sig figs. So we're multiplying and dividing. We're going to count sig figs. 2.5 feet has 2 sig figs. 12 inches in a foot. Remember, the 3-bar equal sign was an exact relationship, and exact relationships have an infinite number of sig figs. So the smallest number of sig figs is 2. To write this correctly, I need 2 sig figs. Right now it looks like I only have 1 sig fig. So I can put a decimal point to make the 0 significant, or better yet, I can write this in scientific notation, 3 times 10 to the first inches.